Hello everyone, welcome to second video of Arduino tutorial. In the previous video, we learned about interfacing of LED with Arduino, mainly digital write function which set either 1 or 0 on configure digital pin. In this video, we are looking for interfacing of push button with Arduino Uno as input device using digital read function which read either 1 or 0 from configure digital pin. At the end of this tutorial, we also control LED using push button. For this tutorial, we required hardware components are Arduino Uno with programming cables, push button, 10 kilo ohm resistor, LED, 220 ohm resistor, breadboard, few jumpers wires. That's it guys. At first we'll see how push button is working. By looking push button, you will simply notice that there are total 4 pins on the push buttons. So in this side, pins which having the longer in distance are internally shorted, whereas the pins which having the shorter in distance are short after pressing the switch. So I have just given the numbering 1 2 3 4 for better understanding. Pin 1 2 are internally shorted, similar to that 3 and 4 are internally shorted. So when anyone press the switch, then this point 1 2 will get shorted with the 3 4. So we can consider 1 2 is a combinedly single pin and 3 4 it's combinedly single pin. So any connection made either 1 2 it's the same. Similar to that, any connection made to 3 4 it's the same. After pressing, only these vertical points get shorted. When we press the switch, so 2 is also connected to 4 or 1 is also connected to 3 after pressing switch. If you see actual switch, in that these 2 points having longer in distance, whereas these 2 points having shorter in distance. When we press actual switch, then these 2 points which I have highlighted, which having the shorter in distance, that get shorted. When we interface push button with Arduino, we require pull down register. Why we require? Let's see. If you look for this circuit, which is common while connecting push button to any of the microcontroller, in that case, suppose the push button is remains open and pull down register is not connected, then pin will remains open state, which is a floating state or in high impedance state. In high impedance state, pin having more susceptible to the noise, means it will pick up more noise, which will leads to unreliable behavior in our logic. So that's why to avoid this uncertain condition, we have to use the pull down register. So to avoid the floating or high impedance state on digital pin, we prefer the pull down register. In our case, we are using pull down register is around 10 kilo ohm. There is always question while connecting push button to Arduino. It's need to connect either analog or digital pin. If you see the digital signal, considering square wave, which having the two value high and low or 1 and 0 with respect to time. So when we press the switch, it remains in any of the states, either high or low, according to how we have designed the circuit diagram. It will give either 1 or 0. But if you see the analog signal, which having the infinite number of the values with respect to time, so if we press the switch or release, it will be not giving continuous values, it will giving the discrete value either 1 and 0. So that's why we are considering push button as a digital device which we need to connect the digital pin of the Arduino. I hope it's clear to all of you. Let's see design of circuit diagram. As you know, we require the components are Arduino Uno as our main controller, one push button. Along with that, there is a pull down register of the 10 kilo ohm. While connecting this push button, we need to connect two digital pin. As we saw earlier also that this section represent digital pin, whereas this section represent analog pins. This section represent the power section. So we need to connect the switch to digital pin of the Arduino. So we can connect any pin from digital pin section to the push buttons. So we are connecting digital pin number 5 to first pin of the push button. Then second pin of the push button is connected through 10 kilo ohm resistor to ground of the Arduino. Then third pin of the push button is connected to 5 volts of the Arduino. So by default, switch is in release condition or not press condition. So we have designed circuit diagram like when we press the switch, it's connected to the VCC. Pin number 5, it's shorted to ground via 10 kilo ohm resistor. So when there is a switch is in open conditions or not pressed, pin number 5 will read the 0 volts, whereas when we press the switch, pin number 5 it's shorted to VCC. That means it's getting the 1 or logic high when switch is pressed. That's it guys. So we'll move to actual hardware connection. So this is the wiring connections of the circuit diagram which we have designed with the help of breadboard that we can refer for making actual hardware connection. So let's start.
Push button does not have any actual direction, so we can use in any direction while connecting to the breadboard. So we will make the connection. Once it is connected, after that we require 10 kilo ohm resistor as a pull down resistor to connect the push button, the Arduino. So we can connect one pin of the push buttons. After that, from Arduino we are connecting any pin you can take. So we have used pin number 5 to connect the push button. Another pin will be connected to the same pin where the register are connected, as these two pins are shorted, so we will connect here. Other end of the register, these are horizontally shorted, so this we connect to ground of Arduino. That goes to any ground pin of the Arduino. No? VCC of Arduino, it's going to VCC pin is connected to other terminal, to another terminal of the push button. So I will connect on this side. Yeah, that's it guys, our connection is done. So we'll verify with actual programming, with writing code.
So guys, we can start writing logic. So for that we can consider this circuit diagram for reference. We need to open Arduino sketch, blank sketch. As we know, by default there is a two functions are available, setup and loop. So setup is the function which execute only once. In that we can initialize different pin modes, either input or output or any others variable that we have to use, that we can initialize with specific value. Whereas the loop is the function which execute periodically, cyclically, where we can write our main core logics, as we have to take the habits of declaring whatever the pins that we are defined above the setup function. Pin number 5, from digital section we are connecting to the switch as input, so we need to declare here. Yeah, pin number 5 we have defined as input to connect the switch, so we can use switch pin instead of 5 in upcoming programs logic. Inside setup we need to update the mode for that respective pin, that is pin number 5, as a input. For that the arguments are our switch pin, the pin which we have declared, which will need to pass the argument as a input and end with semicolon. So here, so pin we have defined as a input, but some of the cases you will see input with pull up. So where to use the input and where to use the input pull up while defining pin as a input. So that we'll see in next. What is the significance of the input pull up and when to use that. Then in loop we can start our main function. In previous tutorial we have using digital write to blink LED, which write logic on digital pin either to set high or low, but in this tutorial we need to read the switch state. So for that we require to use read the state from this pin. So we need to use for that digital read functions. So digital read function in Arduino is used to read digital signal high or low from specific digital pin. So we can write digital read with arguments of switch pin, which we have declared above one, pin number 5, its name, and end with semicolon. So this function will return the switch state either 1 or 0. Later read function will return switch states either 1 or 0 according to switch is pressed or not. So that we must need to store into some variable. So for that we declare here one variable end with semicolon. So same variable we are using below, which will be updated by return value from digital read. In order to see the value of the switch state, we need to print it. In normal programming languages, C or any others, we have console or output screen where we can print value of the variable. But in case of the microcontroller, there is a different concept. Here we need to use the serial communication. For that we need to enable serial port of microcontroller to transmit and receive respective data. So in case of the Arduino Uno, we can print value of the switch state using serial begin function on serial monitor. Once we flash the code, after that we need to enable this serial monitor. But to print value on the serial monitor, first we need to enable the serial communication. So for that we are using serial begin function. Serial begin function will enable the serial communication in Arduino. For that we need to pass baud rate, that is 9600. Serial begin functions we need to execute only once to enable the serial communication. After that, to print serial value every times we need to use another function, that is serial print. Serial print will execute periodically or repeatedly whatever the values that we need to print. First we can write serial.begin. So for that we need to give argument is baud rate, which is 9600, which is commonly used. After that we can print the value of the switch state by using serial.print. Every time when we print the switch state value on serial monitor, it should be print on next line instead of printing in sequence continuously, which will be easy to understand. So we need to write here ln, which indicate for next line. After that we need to give the argument this switch state, as we need to print value of the switch state, and end with semicolon. In order to visible that value, we have to use the delay, as value will be printed on serial monitor very fast. In order to visible to us, we need to add some delay. So we are adding delay of 1000 millisecond. Using this logic, it will always print whatever the current state of the switch. If we don't have pressed the switch, it's in release state, it will print value 0. And when we press the switch, then it shorted digital pin to VCC, and that's why it's print to 1. So that will be continuously printing. We can modify this logic as per our requirement. Now we can flash this code on hardware. Before that we can save this sketch. So it will take time to save. Our program is saved. Now to flash the code, we have to connect hardware with laptop. Before to flash, there is one important step to select the board and the ports on which Arduino Uno is connected to PC. That we can select it from tools, board, from board manager. Below the one there is a different boards are available. So the your specific board, if Arduino Uno Nano or any other controller, that we need to select. After that, there is a second option, ports, for which USB our board is connected, that we need to select. After that we can start flashing by click on upload button. So it will first compile and after that it will upload the code. Yeah, uploading done. So if we open the serial monitor, it will print value as well as blink transmit light as well as blink TX LED. So it will print the value 0. We see clearly as our switch position is open. If I press the switch, it will change to 1. If I release the switch, it will change back to 0. So if we press the switch, it will continuously print 1. This you can see. If we leave the switch, it will continue to again 0. So that's it guys. Now we can modify the logic as per our requirement. When we are using pin mode function to set pin state as input, so either we need to use mode as input or input pull up. So that is always important part while writing the code inside the setup. In above example we saw pin state we define using input as a mode inside the pin mode functions. So where we are using the pull down register that will be useful when switch is in release position. That time it will connect that respective digital pin to ground, which will avoid that pin should be stay in open high impedance or floating state, which will susceptible to the noise, means which taking noise as an input and will be change our logics. To avoid that, to process the noise as input, we have to use the pull down register externally. In this case, circuit is designed like when switch is not pressed or release state, in that scenario, pin will read logic 0 as pin is connected to ground via 10 kilo ohms resistor, and when we press the switch, then pin is connected to VCC. That means it's getting logic 1. So in this case, we required external pull down register. But in second scenario where we need to use input pull up as a mode inside pin mode function to define pin state as input, there we don't require external pull down register. Since Arduino will provide support that Arduino has internal pull-up register which we can enable by using input pull-up as a mode inside pin mode function. In that case, the circuit designed in a different way where our pin will be connected to VCC by enabling internal pull-up. When the switch is pressed, it will connect to ground where switch will be in release state or not press state. Then we will get logic 1 on the digital pin as it will be shorted to VCC, and when switch we will press, that time we should get the logic 0. In this scenario we have to enable the internal pull up register of the Arduino, which is around 50k. So this is a very important concept in case of the what mode when to use inside pin mode function, and that is always asked if you are going for any interview as a fresher or any science exhibition. So that time we need to take care if we are using multiple switch or any digital sensor, so how we have enabled the pull up and how we have written the logic that we need to take care. So mainly difference when to use the input and input pull-ups, that's will be, so if we are using the input, that time we have to avoid the floating state, means getting a noise on the pin which will impact on our logic. To avoid that we have to use the external register, whereas the in case of the input pull-up, by default there is an internal pull-up register is available that we need to enable just using the input pull-up as a mode inside pin mode functions. So it will be avoid excess burden of using external register, as in case of the external pull down register we have power consumptions will be there specific for that, whereas the internal pull up which having the extra burdens of the power, whereas number of the components will be exceeded, whereas in case of the input pull ups there is the no external component is required. Only our logic will be changed that we are right. So if you are talking, Arduino will supports to internal pull-up register which we can enable as per our requirement. So maybe Arduino also supports for internal pull down register. So answer is no. So Arduino will not support for internal input pull down like that commands. Okay, it just supports for the internal pull up register. So if we require any pull down register, that as we discussed in above scenario, so for that we need to use the external pull down register. So we'll see how we can control the LED using push buttons. In addition, with existing circuit design, we require additional component that is LED as well as 220 ohm resistor to control the brightness, or it will be act as current limiting resistor. To make the circuit diagram, we can connect the pin number 10 to anode of the LED via 220 ohm resistor. Then cathode of the LED will be connected to the ground of the Arduino. Yeah, the circuit will be completed. Now we can make the actual hardware connection. Now before to going actual hardware connection, we can first update the logic for it. So we need to use this circuit diagram for reference. So here switch state we have taken. Initially first we need to declare the digital pin which we are connecting to anode of LED, that is hash define LED pin. There is a single LED, that's why we have write LED pin number 10 we have connected. So the pin on which LED is connected, that is digital pin 10. So that we need to set as a output by using the pin mode function. Inside a setup function, we need to update a respective pin state as output using pin mode function. Here also we can update the comment for LED we are set as a output. So we need to write our logic inside the loop to control the LED according to the switch we have pressed or not pressed. So when we have pressed the switch, that time LED should be on. As soon as we have released the switch, LED should be off. As much time the switch is in release position or not pressed, LED must be in off condition. When we have pressed the switch, then immediately LED should be on. Switch state is the parameter where we are reading the switch pressed or not pressed, that we need to use switch state. If switch state is equal to high, then our LED must be, as we already saw in our previous video, to write logic high or logic low on digital pin, we need to use digital write function with arguments of pin name which we need to update. What we need to do, either high or low, that we need to write, that we can put here. So we are making turn on LED. So when switch will be pressed, its state is read as a high, then LED will be on. Else by default switch position it should be released or not pressed, then we are reading as a 0. That means if switch state is not equal to high, it should be in low state. So then we can keep LED off. So that's why we have to keep here digital write to off state. That's it, print. As well as parallelly we can print the switch state on serial monitor. So we can save this logic, and to make additional hardware connection for LED interfacing, we are using this circuit with breadboard for reference. First we will connect LED on breadboard. Once LED is connected, we'll go to connect resistor of 220 ohm. So we'll connect anode of the LED, one terminal to resistor. Once resistor is connected, Then we can connect other terminal of register to pin number 10 of Arduino. So pin number 10 is going to register, and cathode is connected to ground. Ground of Arduino. We can flash our logic and let's see. So we can connect programming cable of Arduino to laptop and start hardware. As board we have already selected, we can cross confirm, as well as the port is also selected. So we can just flash by giving upload. Once our program will flash, as our switch state is remains released or not pressed. Yeah, it's flashing done. So LED remains off by default after flashing, as our switch is in release position or not pressed. That's why LED remains off. Here we can see as push button is not pressed, so that's why the LED will remains off. As soon as we press the push button, LED will start. When we release the switch, LED will be off. As soon as we keep the press switch, the duration for which we kept switch pressed, LED will remains on. When we release the switch, LED will off. If I open serial monitor, you saw here switch status is a 0, as switch is not pressed or it's in a release state. When I press the switch, so LED will be on, as well as the switch status is also changed to 1. When I release, it remains 0. When I press, it will change to 1, as well as your LEDs also get on. So it will change to 0. Yeah, that's it guys. In case of Arduino, there is a concept of serial plotter where we can see the wave of the inputs that will be received from switch to digital input pin. For that we need to change the connection. This additional signal we need to connect to Arduino A0 analog pin. So by default this A0 pin will take the waves, or analog 0 pin is used as the input for serial plotter. If you see near to serial monitor, there is one feature available in Arduino IDE, that is a serial plotter. So for that the signal will be getting as an input from analog 0 pin of the Arduino Uno. Whatever the signal that we want to visualize in the form of waves, that we need to connect to analog 0 pin of the Arduino Uno. If you see here hardware connection, so I have connected the same pin which we connected to the digital pin 5, where we read the signal that will going with another cables to the analog A0 pin. So I will make the same connection on hardware. After that we'll see how it will be, waves will be looked when we press the switch or release the switch. So this is the additional cable I have taken, which I will connect one end into the analog A0 pin of the Arduino Uno and another end into the digital input pin of the switch. Will be going to the 5th number pin. So I will connect this pin first to analog A0 pin of the Arduino Uno. If you see, A0 I have connected. See, This pin I have connected, and other end of the same pin will be going to, so this pin, orange color pin, if you see, which connected to the fifth number. Okay, so other end is going to the switch inputs. So in the same column I will connect this red pin which we have connected to analog A0. Now we can connect and we'll see how it will be look like. So we don't require to do any change into the software, only just we need to make the hardware, and we have to enable that serial plotter. Here I will keep serial monitor also open, will enable and switch and all four things. Okay, we can start. So it will ask, this is a COM7 for which our Arduino is connected, and if I press the switch now, LED will on, as well as the value of viewers in serial monitor will be changed to 1. You see, as well as as we kept the serial plotter 1, as we kept the switch continuous through press, you can see the waveform is also set to 1 in this area, whereas on the serial monitor, yeah, I have left it, that's why it changed to 0. See, this is also will remains 1, your waves is remains 1. As I left, it will become 0, and here also I need to drag this 0. So same way 0. So this, in this way we can plot the graph if we want any value which we represent on the serial monitor. So we can check its graphical representation. We can get the graphical representation for particular values that we are represented on the serial monitor using with the help of the serial plotter. Okay. So this is the very cool features, or this is a very nice features available with Arduino that we can use to analysis. So in this video we learn about interfacing of push button with the Arduino as input device with the help of digital read function. Along with that, we control the LED using the push button. Also we saw graphical representation of the input state, that reading on digital pin of Arduino Uno. So push button having some applications. It will be used to develop basic controls application. One which we took like LED controls. So similar to that, different output digital devices that we can control with the help of the push button. Then if we are developing any menu navigation system, left, right, up, down, or any specific click, so that we can create with the help of the push buttons. Then if any counter and timer based systems will be there, where we need to count how many times the switch will be pressed, or we need to log the time when start and when stop, so that events we can get with the help of the push button. Then any game or any toy we can develop, so where we have to handle the different control to giving the different directions to start the movement, stop the movements, or any other according to the games, so that we can use. Apart from that, in home automation, it is very important role of the push button to interface with any of the controller, where using that we can control the different appliances like light, fan, or any others will be there. Then in case of the robotics also, it is very important to navigate the different directions or any stop start conditions we need to handle with the help of the push buttons. And finally, alarming and security systems, where we can use to enable and disable that respective alarm. So main thing it is to push button is used to control different digital output devices, which we can give the specific event to trigger that output devices. Thank you for watching this video. Stay tuned with us.